Test the convergence of the integration minus infinity to 0 sin hx dx. Let us take I equal to integration minus infinity to 0 sin hx dx. Here the lower integral is minus infinity. Here the lower integral is minus infinity. I am changing this lower integral to as t by taking limit t tends to minus infinity. So I can be written as limit t tends to minus infinity integration t to 0 sin hx dx. We know the value of sin hx, that is e power x minus e power minus x by 2. Now I am integrate this integrand with respect to x. Here you can observe 1 by 2 is constant. That's why I am putting 1 by 2 outside. Limit t tends to infinity, minus infinity as it is. We know that integration of e power x is e power x only. That's why here I am getting e power x. And also integration of e power minus x is e power minus x, and the differentiation of minus x is minus 1. So I am getting minus e power minus x. So minus into minus is plus. E power minus x limits are t to 0. So 1 by 2 as it is, limit as it is. Now I am going to substituting upper limit, that is 0 in the place of x. Then I am getting e power 0 plus e power minus 0. This is the term. By substituting upper limit, I am getting upper limit minus. Now I am going to substitute lower limit, that is t. So e power t plus e power minus t. This is the term what I am going to what I am get after substituting x equal to t. Now I know the values of e power 0 and e power minus 0. Those are equal to 1, 1. That's why I am getting 1 plus 1. Next, I am substituting t tends to minus infinity in this term. So, t replaced with minus infinity, e power minus infinity, minus into plus is minus, e power minus of minus infinity, that is e power infinity. Here I am getting e power infinity. 1 by 2 into 1 plus 1 is 2. E power minus infinity is 0. Y means e power minus infinity equal to 1 by e power infinity, that is 1 by infinity 0. E power minus infinity is 0. Minus e power infinity is infinity only. Here the simplification of this term is 2 minus infinity, that is minus infinity. The simplification of this is minus infinity. Minus infinity by 2 is minus infinity only. That means the given integration diverges to minus infinity. Why diverges means here I am not getting finite and unique value. Next, I am going to test the convergence of integration minus infinity to infinity dx by e power x plus e power minus x. First of all, I am taking I equal to integration minus infinity to infinity dx by e power x plus e power minus x. I am splitting this integration minus infinity to infinity as minus infinity to 0 plus 0 to infinity. This is on spacing of properties of integrals. The integrand is same. For the first integral, I am taking limit t1 tends to minus infinity and replace this minus infinity with t1. For the second integral, I am replacing this infinity with t2 by taking limit t2 tends to infinity. Integrand is same. Consider this as equation 1. Now I am finding the value of integration dx by e power x plus e power minus x. E power minus x can be written as 1 by e power x. Take LCM, that is e power x only. Here I am getting e power 2x plus 1. Here e power x is LCM. Whenever fraction lies in the denominator, it goes to numerator as e power x by e power 2x plus 1. Now I am going to evaluate this integration by using substitution, that is e power x equal to z. E power x differentiation is e power x into dx. Z differentiation is dz. From this, e power x dx is dz. So replace e power x dx with dz. Here I am having e power 2x. So I need e power 2x value, that is z square. So substitute all values. Then e power x dx is e power dx is dz. Next e power 2x is z square plus 1 as it is. I know the formula for integration of 1 by z square plus 1 dz is tan inverse of z. Replace z with e power x. So finally I got the value of integration dx by e power x plus e power minus x as tan inverse of e power x. Substitute this value in equation 1. Then RHS becomes limit t1 tends to minus infinity tan inverse of e power x. Limits are t1 to 0. Limit t2 tends to infinity tan inverse of e power x. Limits are 0 to t2. Limit as it is. First I am substituting upper limit 0. Then I am getting e power 0. Next I am substituting lower limit in the place of x. Then I am getting e power t1. So after substitution of limits in this term, I am getting tan inverse of e power 0 minus tan inverse of e power t1. Next, limit t2 tends to infinity. Here also I am substituting upper limit. Then I am getting tan inverse of e power t2. After that, I am substituting lower limit in the place of x. Then I am getting tan inverse of e power 0. That means after substitution of upper limit and lower limit, I am getting tan inverse of e power t2 minus tan inverse of e power 0. I know the values of e power 0. Value of e power 0, that is 1. Y means any number power 0 is 1 only. Next I am substituting in the place of t1 minus infinity, in the place of t2 plus infinity. E power minus infinity is 0. E power infinity is infinity. Tan inverse of 1 here. Plus into minus is minus. Tan inverse of 1 here also. Cancel those two tan inverse of 1s. Then I am getting tan inverse of infinity minus tan inverse of 0. Tan infinity can be written as tan pi by 2. 0 can be written as tan 0. The simplification of this term is pi by 2. The simplification of this term is 0. So, pi by 2 minus 0 is pi by 2. That means I am getting finite and unique value. That means given integration converges to pi by 2. Test the convergence of integration minus infinity to infinity dx by 1 plus x square. Here also I am writing integration 0 to infinity as minus infinity to infinity as minus infinity to 0 plus integration 0 to infinity. This is the splitting. I am splitting this integration as two integrals. Integrand is same. In the next step, I am replacing minus infinity by t1 by taking t1 tends to minus infinity. And also, in the second term, I am replacing infinity with t2 by taking limit t2 tends to infinity. Next, the integration of dx by 1 plus x square is tan inverse of x. Here also same term is there. That's why integration is tan inverse of x. Now I am going to substituting upper limit and lower limit for these two terms. Then I am getting tan inverse of 0. But tan inverse of 0 can be written as tan inverse of tan 0. That means 0 only. That's why I've written 0. Lower limit substitution tan inverse of t1. Here upper limit substitution tan inverse t2. Lower limit substitution means same thing only. This is 0. Now I am going to substitute apply limit t1 tends to minus infinity. Then I am getting minus tan inverse of minus infinity. Here tan inverse of infinity. But we know that tan inverse of minus infinity value is minus tan inverse of infinity. So infinity minus into minus is plus. So the simplification of this term is tan inverse of infinity. Tan inverse of infinity plus tan inverse of infinity means 2 tan inverse of infinity. But we know that infinity can be written as tan pi by 2. That means tan pi by 2 is infinity. That's why I am replacing infinity with tan pi by 2. The simplification of this term is pi by 2. So cancel 2 and 2. Then I am getting pi. Pi is also finite and unique. Therefore, the given integration convergent and its value is pi.